Hello children, welcome to channel Sube. Children, today I am going to discuss question number 1 from the MCQ part of 2021 Physics New Syllabus paper. Which of the following pairs of physical quantities have same dimensions? Stress and strain, work and energy, velocity and displacement, weight and mass, torque and angular momentum. So children, when we look at this question, it is very easy. At first glance, we can choose that this answer is correct, because in this lesson, the dimension, we teach that what are the dimensions, and after doing all those calculations and exercises and examples, we give them a short note, that means a brief summary. So there we say what are the physical quantities, those have same dimensions. What are the physical quantities, those have same units. What are the physical quantities, those don't have units. What are the physical quantities has no units, no dimensions. So like that we give them a summary. So if you remember the summary, we write there the dimensions of work equals to the dimensions of energy. That note you must have. Then if you remember that, you can just select this answer. You don't have to go deep. But children, to be very useful this video to everybody, I am going to explain all these things. I am going to find out the dimensions of these all physical quantities, because in the next examination you might have something like this or something like this, something like this. We don't know. So therefore I am going to do all these things. So children, now let us take this first one. Stress and strain, the dimensions they say are equal here of stress and strain. So we have to write the equation where we find this stress and strain. In this equation, you must know this equation. If you have studied the lesson called elasticity, so there we meet this equation formula. Young's modulus equals stress divided by strain. So in symbols, if you use symbol Y, or sometimes they write capital E, Y or E equals stress. Stress means, what is stress? Stress is force divided by area. Force divided by area. What is strain? Strain is E divided by L. So here in this equation, F is force, then capital A is area, then simple is the extension, and L is the initial length. Or we can say original length. So if you calculated these values after substituting to this equation, we get the Young's modulus. So children, we know in the laboratory, in the lab, what we do, we hang a wire to the roof like this, and fix the wire to the roof, and then we measure the initial or the original length. This one we measure using the meter rule. So then what we do, we hang a weight here and give a force to this wire, say F, that F equals mg. Then what happens to this wire? We can see it is stretched and show an extension like this. So the initial level of this end, say this level, and finally the level of the end is this one. So initially this F is 0 actually. After coming to the equilibrium position, we can measure this force as mg, because as soon as we hang this weight, what happens, the wire goes to the extension and come to the equilibrium position. So it takes very tiny little time, so we can't see this one. Actually it is 0. The initial force is 0, gradually it increases as while we release the weight from our hands, because at the beginning we keep the weight lifting. So as we release the weight, so this wire stretch and show this extension. So this length is called extension, simple E. So we can measure these things and apply to this equation and find whatever we need. So in this question what they ask is dimensions. So using the equation we can find dimensions. How? So now we have to find out whether the dimensions of this stress is equal to the dimensions of strain. So we have to check this one, F divided by A, because that is what we call stress. So F divided by A is stress. So the dimension of that term we have to find out. So to denote it, the symbol is this bracket, this square bracket. So is equal to, so we have to substitute the dimensions of F. F is force. What is the dimensions of force? M, L, T minus 2. You must know these things if you have learned the lesson properly. If not, I will teach you after a while, after I solving this problem. So for the moment keep in your mind the dimensions of F is MLT minus 2. So divide by the dimensions of area. What are the dimensions of area? L is squared, because say this one is the area, so this width and this side we have to multiply. So I have to save before, otherwise something happened. So we multiply this width and this length or breadth, W times L. So this width is a sort of length, this breadth is also a sort of length. So therefore length times length is equal to length squared. So like this we get. So we can cancel this one, then we get the dimensions of stress is M, 1L remain here, so we can take it up. So L minus T minus 2. So this is what we obtain. So now let us try to find out the dimensions of strain. Strain is E divided by L is the extension. So extension is this one, so it is a sort of length. So the dimensions now we are going to take, therefore we write square bracket. So dimensions of E is a sort of length. So dimensions of this original length also is a sort of length. So cancel each other, we get no dimensions. Therefore we can't say these two are equal, because this one has dimensions, this one has no dimensions. So therefore this one is wrong. So now let us discuss the second one, work and energy. So what is work? You must know work is force times the displacement. So the dimensions of work now we are going to find out. So the dimensions of force is m, l, t minus 2. So that you should have in your mind. By heart you should be able to write it. So times d is a sort of length, because if we push the, say, a box on the floor so that it moves towards this place, so the force we applied is F and the distance it travelled is the d in this equation. So that is how we calculate work. So therefore d is a sort of distance, so sort of length, it is a sort of length, so therefore capital L. So simplify, m l squared t minus 2. So that is the final dimensions of work. So what is energy? Energy, you have to remember two simple energies we know, potential energy and kinetic energy. If we take the kinetic energy or potential energy, whatever it is, as example, we can write mgh is the potential energy. Simply, you know, even in class 2 grade 8 we know the potential energy is given by mgh. So we can use this equation. M is the mass, so capital M is the dimensions. So g is a sort of acceleration, gravitational acceleration we say. So if it is acceleration, what are the dimensions? L t minus 2. Because using units we can derive it. Units, what are the units? Of acceleration? M s minus 2. So m is what? Meter, not mass. M is meter. So if it is meter, so it is a sort of length. S is time, seconds, so that you don't get confused. But this m here you might get confused. Keep in your mind. I even get confused sometimes. Instead of m I write sometimes capital M. I have written because that is wrong. M is meter. Here m is meter. Meter is a length. Because we write capital M here for simple M. So the same way you might write here in the wrong form. So therefore keep in mind that. So the dimensions of G is then L T minus 2. So what is this H? H is the height of a mountain or something. Height is a length. It is a sort of length. So we get like this. So m l squared t minus 2. So here you see equal. This one and this one equal. That is why we choose this answer as correct by heart without deriving all these things. So that is it. So children, here itself, as we did this thing, acceleration, I will finish the finding the dimensions of force, because I discussed here. I promised you that I will show you. If you don't remember this one, later I will show you. So this is the time for that now, because I have already derived this one here. So force equals, you know, Newton's equation ma. So you can use that to find out dimensions of force. If you don't remember, this is the way. Dimensions of force must be equal to dimensions of mass. So that is, if it is mass, capital M, it is a sort of mass. So acceleration is this one. So L t minus 2. So here you get mlt minus 2. You have to keep this in your mind, because all the times you can't spend time to derive this, because most of the times we need to write dimensions of f. Therefore you have to keep it in your mind, like we did here, mlt minus 2, you have to quickly write. So now we finished the second one. Now let us go to the third one, velocity and displacement. So children, what is velocity? Velocity is the rate of change of displacement, delta s divided by delta t. You must have learnt this equation. Delta s divided by delta t we know as velocity. So what is this s? S is displacement change. So if we measure from the initial point, then this delta we don't want, just we can write s. We need this delta if we start to measure, the starting point is somewhere other than the starting point. So the car starts to move from here and goes this way. So if we have decided to measure all the displacement from a certain fixed point like this away from this other than this starting point, so then you have to find, then you have to measure s1 first and then s2 second. So the length, the distance the car moved is delta s, we say, that is s2 minus s1. So that is how this delta comes, and we take time as delta t, because the time from here to here is taken as delta t. So if we decided to take this pole, take this point to this starting point, so we don't need the delta story, just the displacement s. This one only we know, this one is 0, at 0. So therefore this delta is not essential, so you can write just s is displacement divided by t. We use s instead of d for displacement. The symbol is s, because you know s equals ut plus half at squared, and v squared equals u squared 2 times a s, like this. So then v equals u plus at. So these are the basic equations we use in the lesson motion. So we don't use d normally, we use s. So this is the equation. So s is a distance, however is a length, so it is a length. So L, the dimensions of velocity, just we can write v, just we can write v equals, but not just v, we have to write the brackets, because we are now writing at the right side button dimensions, not values. Therefore is a distance, s is a distance, so t is a time. So what we get in L t minus 1. So this is the dimensions of velocity. So displacement, what is the displacement? It is the straight distance to a certain point, straight distance. So this is a length, this one is s, displacement is s. if we write the symbol, it is just S. But we have to get the direction. So directions has no role to play with this dimension. So therefore we don't have to consider the direction, even though it has such a direction. But we just have to choose. We just have to decide whether it is this measurement is a length or a mass or a time. That is what we have to do. So we know it is sure this one is a length. Therefore we write the dimensions of displacement. That means dimensions of S is just L. So they are not equal. They say velocity and displacement have same dimensions. No, that is wrong. So this one wrong. Now let us save first of all. Children, now let us take this fourth one, weight and mass. What is weight? Weight is, the gravitational force. F, weight is, we write W, so sometimes we write F, F equals mg. So like that, weight is equal to m times g. So m is the mass. So if we want to find out, normally we write F, W, weight. The dimensions of F, dimensions of W is equal to dimensions of mass and the dimensions of G. So we know the basic dimensions here. M is capital M. So what is the dimensions of G? G is a sort of acceleration. So if it is an acceleration, then we know what are the dimensions. LT minus 2, because we already have discussed that here, LT minus 2. So simplify, dimensions of weight is MLT minus 2. So that is the force. Weight is a sort of force, because the same MLT minus 2, the dimensions of force also MLT minus 2. So now what is mass? Mass is just we write M, just M. We write just like this, M. M is mass. So that is basic. So dimensions of mass is equal to what? Capital M. Because when we write dimensions, we must write capital letters, capital M, capital L and capital T. So obviously, are they equal? No, they are not equal. This one is this one is this. So they are not equal. Therefore we have to say this one is wrong. So already this one was wrong, this one was wrong, this one was correct, and I have to now show this one, discuss this one. Torque and angular momentum. Let us take this down, then easier, I don't have to type all these things. Torque and angular momentum. So children, what is torque? Torque is, we symbolize it where the symbol for torque is tau. Tau equals force times the distance d, force times d. This tau is this one. In character map you can see this one, Greek letter tau. Here you see mu, theta and also tau here. So that is how we write tau. So tau equals F times d. F times d means what you need is torque to remove a tire from a vehicle. So to remove the tire you have to loose these nuts. So there is a tool, having a long crossbar like this. Then there is a we call it a box spanner. Box spanner is a thing like this, is a cylinder like this shape, and it exactly fits with the nut like this, so we can easily loose it by using this tool. So sometimes you must have seen when they remove bus tires and lorry tires, they sometimes stand on this and jump up and down to get this loosened. So this force is given like this, F, and this distance, this one is the distance. As much as we increase this distance, it will be easier to loosen this bolt and nut. So this one is torque. What we give is a torque. Torque means a force and a distance. So when we multiply this, we get the value for force. So that is what torque is. So force times D is we call torque. So now we are going to find out dimensions, of torque. So we have to find out, we have to write the dimensions of force. So that we know already, M L T minus 2. So this D is a distance, perpendicular distance. So it is a distance, so it is a length, therefore L. Then we get M L squared T minus 2. So that is the answer for this part. So what is angular momentum? So now children, let us look at this angular momentum. What is angular momentum? There are two ways to explain what is angular momentum. The normal one is, we can write angular momentum like this because it has no standard symbol. So angular momentum is I omega. You know conservation of angular momentum. There we write I omega equals I1 omega 1 plus I2 omega 2, like this. You must have experience if you have done those exercises, problems. So that we can use. Angular momentum is I times omega. What is I here? It is we called inertia. So I am not going to explain it because it is a deep thing. It is a deep thing. We need a lot of time to explain it. So you must know what is inertia is. So inertia, it has a equation. So knowing that is enough for the movement. I equals mr squared. There are various types of equations for various types of geometrical objects, but just for a point object, the inertia of a point object is mr squared. So that is enough if you know that. What is omega? Omega is angular velocity. So that you know. So then you have to use, you can use this one to find out the dimensions, and also for omega you can use theta divided by time, but you will face problems when you are going to do this with theta. But there is another equation to find out the dimensions of omega. So let us look at that after a while. So first let us do this. So to solve this, first of all you must know how to get the dimension of theta. It is difficult a little bit if you don't know the lesson. It is not just the degrees as we usually do in the classroom. So this theta must be measured by the unit called radian. So you must know how to get angle using the unit radian. So imagine that there is a circular path like this. So this one is the radius, radius. So there is an object here initially on this circular path. The distance from the center is r, so this distance is r, radius. Then this object moves around this path to this place, and while it is moving from this place, we take the angle like this. So that angle is theta. So we have to take it in not degrees, in radians. So we have to measure this line, this curve line, so that we call the distance from here to here, we call s. We take it, we call it linear displacement, linear displacement. So theta we can get in radians. How? Just you have to divide s, the length of that curve line, by r. S divided by r is given, r gives the value of theta in radians. So this what we have to find out is the dimension of theta, because we have to substitute here. So we have to then find out dimensions of these two, s divided by r. So the dimensions of s, this one is a length because it is a distance. So L divided by, what is the dimensions of this r? R is radius, radius is a distance, so that also is L. So cancel each other, so no dimensions we get for theta, no dimensions. Therefore, since theta has no dimensions, here we don't have, we have nothing to write in, no dimensions. So just in the denominator capital T. Then we can write just 1. When we take this T to the numerator, it becomes T minus 1. So this is the dimension of omega. So what I was going to tell you, the other method is this, from the definition. So I am teaching everything, not just what you need to this problem. I am teaching everything, because if you don't know these things, then you don't have to go to another class. You can cover it from here itself. So the definition is of this no, that I am going to do here. So let us save first. So the other method of finding the dimensions for omega, you know the equation V equals r omega. It comes under rotational motion. So here you can isolate omega equals V divided by r. So omega dimensions of velocity, what? L T minus 1. Dimension of radius, this one is radius, r. It is a sort of length. Then it is a sort of length L. Then only T minus 1 you get, same as you got in this method. So however, now you can use two methods, but finally you get the same answer. So now let us come to find out the dimensions of this inertia. What is inertia? I have already written this equation, formula I equals mr squared. So directly let us, without talking about inertia, because it is a deep topic, so just what is this? Mass. So capital M. So first of all I will write mr squared here times omega. So now we have to find out the dimension of this right side. So dimension of M is capital M. dimension of r is length, it is a length because radius it is radius, so L is squared. Omega we found now t minus 1. So this is what we get. This is what we get. Angular momentum. What they say is those two are equal. Here torque and angular momentum have same dimensions. Have they? Have they? So this one torque, torque has ml squared t minus 2. Here angular momentum has ml squared t minus 1. T minus 1. Here t minus 2. So it is not equal. It is not equal. Therefore wrong. This one wrong. Now done. The question we have done. I think children, you are happy. I explained everything. Explained everything, even these simple things I explained. So you must be happy. Then I will be happier if you subscribe my channel, you know that. So please do it. Watch my videos again and again. Come to this channel usually. So you will learn something. Something, not something, everything. You will learn everything. So thank you very much for watching my videos. Thank you very much for the people who have already subscribed to my channel. Then see you tomorrow. Goodbye.